who is the cataloguing coordinator for ProQuest. Based in their office in Ringwood, Hampshire, he is responsible for MARC cataloguing for print and AV materials, which are sent shelf-ready to institutions in the UK and worldwide. He studied semantic web technologies at Linköping University and primarily develops in Python. So over to you.
Okay, thank you. So yeah, thank you, Philip, for the introduction, and to all the organisers. Thank you also to, I'm saying this while I share my screen, thank you also to all the presenters. Some interesting things discussed this week so far. So what I want to talk about is MARC, that being a shorthand for MARC 21 bibliographic. And in particular, I want to talk about a feature of it, which is its repetitiveness, or its redundancy, as I've called it here in my title. What I mean by that is that a single fact about a resource, hang on, it's not letting me, there we go. A single fact about a resource might be represented in 2 or more places within the MARC records. So for my example here, I've just identified 3 elements within the MARC record that have some degree of overlap. I'm not saying that these elements are doing exactly the same thing, but just that there is overlap. And also on the slide there is relator term. Now that has no overlap with the illustration codes, other physical details, and so forth. But if one were to, for example, use the code illustrator, then it's a pretty strong inference to say, well, the resource therefore must have illustrative material, and you're going to get something like this pattern on the left-hand side, where there are going to be certain patterns that are consistent, and that's one for illustrations. I'm just sort of leaving aside complications with regard to maps and photographs, just for the sake of getting something on a slide. Now, so that this doesn't become too hand-waving, what I've done is I've snipped out from our sort of overall MARC validation code and simplified it, such that I can run snippets of it in a Jupyter notebook. If you're not familiar with what that is, it's just a platform for sort of writing and running little chunks of code. So I can then print out a MARC record here, which has some deliberate errors in it. And just to hone in on my previous example, I'll reprint the areas we were talking about. So we've got a 008 field here, and there's nothing been coded in the position for illustrations and so forth, but we are saying that there's illustrations in here. So it's a reasonably trivial check. There's something in the way of my mouse there. There we go. It's a reasonably trivial check to then say, well, that there's a mismatch there. So that's error detection. Can we take that one step further and have some sort of automated error correction? And in this case, I'm not sure that we can really, because I don't know, without re-examining the resource, I don't know what side of that equation, as it were, is wrong. Now, we do have some evidence to suggest that we've got still image, because we've got that as a content type. There's a sort of 2 against 1 scenario there, but not really, because I don't know necessarily the conditions under which this MARC record was created. Was it the case that there were 3 separate edits, as it were, going on in the 008, 300, and then 336? Or was it the case that 33X fields even were being created off the back of some internal data that was already there? Without knowing that, I don't think I can necessarily trust it in that way. And something I think sometimes would be useful is if we could have formal definitions of the conditions under which MARC records were created, beyond simply the cataloging code that they were aiming to be conformant with. Now there'd be no room to put that within the MARC record itself, but you could certainly host a formal definition like that externally and link to it. And when I think of linking external data to MARC records, I'm sort of minded of the effort or efforts to move bibliographic description to a linked data environment, perhaps in its BibFrame flavor, perhaps not. And again, just in my own head, that sort of boils down to a sort of 3-phase scenario where you've got this promised land of better resource discovery. and you've perhaps got initial efforts to prepare one's data. Common one at the moment seems to be representing the entities that are contained within MARC records in $0 and $1 as URIs, and we've already seen in some other talks this week examples of that sort of thing going on. But in order to start filling in this question mark, well, what is the value of these URIs in MARC records? What is the value of looking at external data? Is it just the case that these URIs are sort of waiting for their prints to come? They're waiting for some sort of MARC to BibFrame conversion to be run on them, or is there more that we can actually do with them? For now, though, I will just cycle back to this issue of validating records against internal inconsistencies. What I've done, I'm not going to suggest that this is in any way exhaustive, but on the left-hand side of the slide, I've put down areas of description where there's going to be the potential for two or more elements to represent the same fact with a degree of overlap, not necessarily doing exactly the same thing. Place of publication, the value in the $260 or $264 is not doing exactly the same thing as the coded value in the 008, but there is an opportunity for spotting inconsistency. NEW space YORK in New York does not exist in ENK England. So if that's the first value in your 26X and you've got a code of ENK, well, that's inconsistent. So for all these elements on the left-hand side, it's possible to programmatically enforce consistency. My contention being that the more consistent data is, then the more likely, at least it is, that it is actually correct. Now on the right-hand side, what I've done is I've picked up some work that NISO have done recently, where they identified 5 essential metadata elements. And I think that's reasonably uncontroversial as to what they are. Titles, names, dates, book identifiers, subjects. Are these ones which we're saying are, or which NISO are saying are essential, super important? Are they well covered by the elements on the left-hand side, where you've got this sort of double entry bookkeeping style of enforcing consistency? I mean, dates are certainly there on the left-hand side. I think book identifiers and subjects are covered to some degree. Subjects, particularly if you're working in multiple thesauruses, or if you've got some sort of form subject heading going on. The previous presentation mentioned about, I think it was exhibitions, where you might also be able to pick up keywords in records of one sort or another. But titles and names, I think, are less amenable to that sort of validation from the internals of the record. I mean, you can do spell checking with titles, but it's not quite the same thing. What am I going to do now? So to start on the slope of validating against external data, I'll just print my record out again. And this time the thing that I'm concerned about is this value here, $072.2, and I've got a code of UK ZLC, which is nonsense. And I know it's nonsense because the appropriate values for that come from this page here, as far as I'm concerned, hosted on Library of Congress. Subject category codes, we've got them all here, and there's a fair bit of structure behind this page. So we've got the codes here in bold. If there were any depreciated ones, which I don't think there are, they'd have a little dash before them. And then underneath a description of what they actually are, sometimes in the form of a link. And if you're very lucky, that link might then take you off to something which is machine readable. So the structure of that page means that it's easy to get hold of what those codes actually are. There we go. So I've got a list of all those codes there, so I can pass my record through that list, as it were. And on the first line, I can immediately say, well, look, that's not a valid source code. So again, I've got some error detection. My next line down, I suppose we can call that error suggestion. Now, you could take that a bit further and have some sort of automated correction. Now, the reason it's able to sort of suggest that perhaps that's what I meant, and indeed that is what I meant, is because of all those valid codes. That is the one that you can get to from the invalid one in the shortest number of edits, as it were. It has the shortest edit distance. So you could play around with that algorithm and say, well, beneath an edit distance of such and such, just change that, just make an automated correction. As it happens, that I think isn't actually that useful to me in my job, because our way of working is just solidly individual book in hand cataloging. So there's always an opportunity just to pass something back to a cataloger. I don't need to do that sort of thing. that sort of automated correction. But again, as per previous presentations, other people are in the flip side of that, perhaps, where they are just working with enormous data sets and they couldn't sort of do that sort of hand changing. So what if I can move away from using data that is within the sort of MARC library environment to using data that is truly external? And what if I could use data that is self-describing in a sense? Because in here we've got the structure, but there's no indication really of how you're supposed to use this data. I've had to program in the logic of that, to program in that it's the 072 field I'm interested in, and other things that I've just skipped over. Them, the codes themselves might have addition statements appended to them and things like that. So external data, self-describing data. So I'm leading up the garden path here of linked data. My first example of which is going to be from Wikidata. Now I'm not going to go into massive amounts of detail as to what Wikidata is, because that is the subject of the following presentation. So this is just a sort of aperitif for that. But a thumbnail sketch, which I've written down. Wikidata is a collaboratively edited knowledge base, a freely available data set of linked open data, and it provides a web API for working programmatically with that data, which is what I will now do. So a different MARC record this time. Print it out. Here we go. And this time, the internals are all consistent. They're all fine as far as I'm concerned, but it's inconsistent against the real world. What I mean by that is we've got Professor Brian Cox in here, and we've got Cox Brian in here, but this is the wrong Brian Cox. The boyish TV physicist was not born in 1946, but there's nothing sort of within this record to indicate that this is actually the wrong guy. In a edge cases, you could perhaps do something with the value in the $D, but I mean not in this case anyway. So what I want to do is I want to get hold of some information about this chap, Cox Brian, 1946. So I'll do that here, chugging its way through. So one of the things I've been able to get hold of with regard to Cox Brian 1946 is his identifier as per the id.loc service. And cycling back to my a previous point, I've been able to do that because I know the conditions under which this record was created. It's not necessarily apparent from the record, but I do know that the name authorities have been done as per Library of Congress. So I can get hold of this this value here. I can then plug that value back into to Wikidata and get back some extra information. In the interest of brevity, actually, I'm not going to do that in my browser. I'm just going to show what it would look like on some pre-prepared slides. So the structure of Wikidata is such that you have items, and then those items have statements being made about them, and the statements take the form of a triple, essentially. So an item, Brian Cox, this is the Brian Cox we're interested in, has field of work acting. And then if we were to look at acting, Dewey Decimal Classification of 792028. So that was the information that I wanted, and I was able to pull back programmatically. Incidentally, this Brian Cox, it's the Scottish actor who was in Manhunter, the Hannibal Lecter film. Just to visualize what that looks like, I've got my Wikidata data. I've got a graph of that, and I'm trying to pull a particular subgraph of that out, a subgraph that matches a particular pattern. So I'm using, this is the actual bit of programming that I've used. I've used a query language called SHACL, which I've put on the top of this slide here, not with the intention of going through the syntax of it. What is the significance of angle brackets and semicolons and stuff? That's not important. What I think is important is that the logic of the query language matches the logic of the data set. So the data set triples that sort of conjoin with each other to form a graph. The query language is formed by describing graph patterns. And then I can plug a variable into that, the variable being the Library of Congress identifier, and then pull out individual bits from the rest of that graph. So if I go back to my my sort of validation check. Now this is extremely crude. What I've done is I've just said, well, look, if the The Dewey classification that the person is associated with, if the first digit of that does not match the first digit of the Dewey that's in the bibliographic record, so the Dewey main class, suggests that is potentially an error. Now, that is not for a second to suggest that people can't be multidisciplinarians. You know, that would be absurd, but it is just because this business of attaching names to works and thereby attaching persons to works is so important that it is worth having some sort of double check. This wasn't really covered in the internal validation just in the MARC environment, but I can find some way of double checking it. I'm not exactly replicating the repetitiveness or the redundancy of MARC because I'm only looking in one data set. But if I were to expand on this and then start looking in other data sets where they're not just blindly copying the original data set, but where they are giving me back the same information about Cox-Bryan 46 or very strongly overlapping information, then I can start to sort of put in weights and become more sure of the fact that this guy actually is an actor and that it is therefore somewhat doubtful. I mean, it's certainly not impossible, but it is perhaps somewhat doubtful that they are the right person to have been selected for a work that has been classified at a science number. And in this world of sort of extra data sets and such, I think if you were at Jane Stevenson's presentation, I think that was yesterday, that one, if you weren't already before, you will have got a sense of what's out there. And she had sort of DBpedia and VIAF on her screen, or just the idea that one can set up one's own data set. Which is actually what I'm going to do now. I'm going to connect to a data set. I'm going to connect to a data set that this one now is local. This is just on my machine. But it's a data set of bibframe records or bibframe descriptions. Connect to that, and I'm just going to continue on with this this notion of finding imposters based on the classification of the books that they are supposedly contributing to. So now what I want to find within my data set is I want to find a pattern like this, where I've got a Library of Congress subject heading, which has been assigned to two different books. Those books have different classifications. The Library of Congress subject heading may not be the most important one for each of those books. So I'm going to start off with a Dewey of 53012, which is quantum theory. And again, in the interest of brevity, I've sort of coded this as individual parts, but I'm just going to run through this in one clump. Again, you can see that I'm using a SPARQL query here, so I'm sort of continuing on with this theme of using patterns to find the data that I want. And I end up with this result. So of all the sort of bibframe descriptions that I've got, I can say that the classification of 53012 has this distance of 1. It's a pretty notional distance. I mean, you could argue that really the distance is 4 there, but it's the shortest way to get between two Deweys in this structure. So I've just notionally called it 1. So there is a sort of tight cluster of Deweys here that is more targeted than just looking at the first digit or just looking at the first 2 digits. I mean, not surprisingly, most of them actually do share the first 2 digits. They're on physics. This one, which I've said is tightly connected to quantum theory, is quantum computing. So that kind of checks out. This one is science and technology considered as agent of social change. So it's somewhat of an outlier. And if I were to spruce this up a bit and put in the concept of weight, that would probably start to look like an outlier, and I can maybe even get rid of it. But the logic here being that I'm going to say, well, look, any author where I'm happy with them being associated with this Dewey, I'm just going to pass it through if they then start writing books on these subjects because they are so similar. On the other hand, if they suddenly become attached to works about religion, I'm not going to do anything automated, but I'm just going to push that one back to Cataloger and say, well, are you sure? Have you perhaps picked the wrong person from your authority list? You know, have you just gone one person too far or something like that? 999 times out of 1,000, I think the cataloger would be sure, would regard it even as a sort of impertinence to be questioned. But again, just being so careful about attaching the right people because of the that being an essential element. So if I can bring it up on my screen, which hang on, I might have to play about with my screen a little bit. Okay, here we go. So I've got the just a sample page from the MARC format here. Now, the wording from the previous presentation about MARC format was that it was, I think, reasonably good was the wording, but it was said with something of a grimace. This is structured. You know, we've got a valid field up here. We've got whether or not it can repeat. We've got which indicators are valid, which subfields are valid, whether or not they can repeat, all that kind of stuff. But if we start scrolling down, we get into sort of text that needs to be interpreted by a human being, and we've got things about, you know, this field cannot co-occur with this field, or if this indicator is present, then this subfield must be present. If this value is present, then these values must come from a list or something like that. So to work with that, again, if I can, I'll quote from a previous presentation. Someone suggested this was backbreaking, to get all this into some sort of formal data format, or some sort of procedural code, you know, fx do y. It's difficult, and that's before we've even gone into conforming to a cataloging standard, RDA, or using ISPD punctuation, for example. Now, the thing that I like about the linked data stack, the RDF stack, is that it is almost true to say that it is, I don't need that anymore, get rid of that. It's almost true to say that it is almost RDF all the way down, turtle all the way down, as a sort of bad pun. And my sort of final example of that is SHACL, which stands for, or means, Shapes Constraint Language. And it is a language for validating RDF graphs, which is itself written in RDF. If you lay aside the sort of the bootstrapping technicalities of that, if I imagine it in my head, I sort of picture one of those children's toys where you have blocks and apertures, and you try and push the block through the aperture, and you know, that's how children learn about shapes. In SHACL parlance, these blocks would be data graphs, and the apertures would be shape graphs. Data graph, for example, being a collection of bibliographic data. Can you put the block through the aperture? Can you validate your data against a series of constraints? So some examples of data here. On this slide, what I've done is I've put up three very, very minimal bibframe graphs. So they all work by having an identifier which has a type bibframe works. These are all instances of bibframe works. Just to make them slightly easier to talk about, I've given them all a label, a title of sorts. And the bottom two have content types associated with them. This middle one has TXX, the point being that actually that's not valid, that's not a proper bibframe content type. And you could find that out through other methods. You know, you could ping that location, and it would come back saying this isn't allowed. But what I'm going to try and do is keep everything under the SHACL hood, as it were. And the bottom one has a content type that actually is valid. So back to my notebook, I'll just load those in. And then if I print out that final bibframe graph in a slightly more formal layout, again, not to go into the syntax of this in any great detail, but the point being that there's a pattern of three-part statements here. And then if I print out my shape graph similarly, rather more complicated, and there's probably better ways of doing this, to be honest, but again, just in the interest of trying to simplify the tool chain. A notional identifier here, and then some descriptions about what it is that I'm trying to do. So I've got a comment to myself. Target class of BF work. So what I'm going to try and do is I'm going to try and impose this shape on everything that describes itself as a BF work, and I'm going to say it has to have a BF content which is valid. So it comes from this list of valid ones. I'm not, for the moment, I'm not worrying about what if it has one valid one and one invalid. I'm just trying to do something very simple. So a little bit of procedural code to sort of push the block through the aperture. And I get a whole ton of stuff printed back. And if you might have noticed that in previous instances where I've had some sort of error message generated, the wording has been very terse, simply because I've had to go in and type it out, and I'm lazy. I don't want to do lots of typing. The benefit of SHACL is that it gives me, the SHACL language is that it gives me this formal validation report. So if I go through these through these three graphs, the bit of the validation that I'm interested in is just this false here. So I've got a Boolean value of false up here, and then it appears again as text down here. So false meaning that the block has not gone through the aperture. This one didn't, because it didn't have a BF content type. I was trying to say that everything must have at least one valid BibPrint content type, so that fails. Similar to this one where it had a BF content type, the type was invalid, that one also fails, comes up false. And it's only this bottom one where it has a BibPrint content type and it's text and everything checks out. That's the only one where I'm getting a report of true. So in a sort of workflow scenario, I could just ignore that. Basically, I could say, well, that's true, fine, go on to the next stage. Whereas these other ones where they're coming out false, the formality of the validation report is really useful, because in realistic scenarios, you're not going to have these tiny graphs suitable for cramming onto a slide share. What you're going to have is a big clump of data. But if individual bits of that data do not conform with what you want them to conform to, you can pluck those out. And I've got the actual focus node, so the first part of my triple, I've got the result path, so I've got this second part, and I know what should be happening. So I could, in that scenario, push that back to a catalogue and say, this individual bit of data needs attention. You can ignore the rest of this enormous graph and just fix this one thing. So the larger point, I think, about why I wanted to finish with that and make that my final example was that when people are talking about the linked data or any other shiny new bit of kit, I think it's very tempting to talk about that as in terms of resource discovery. As per this morning's presentation, how can we enhance our existing data? But I think there are also opportunities in tandem with that to knuckle down on data quality, something that we already sweat over to great degrees. But if we have another tool, well, perhaps there are opportunities for getting that even better and having even more consistent, even more hopefully correct data. Which I think is probably I've probably talked for enough. So I will stop it there and see if there are any questions or comments or whatnot.
Thank you very much, Duncan. That I feel the technicalities of that may have gone over my head to some extent, but I think anything that that helps us to resolve the Brian Cox conundrum, which is the great name authority issue of our age, is pretty significant. If you could clarify, when you're talking about working with the linked data, referring to things in Wikidata, you're using Library of Congress identifiers.
In that instance, I was.
Yeah.
There would be potentially other paths into Wikidata. Any sort of bit of data that's in there, if you can get hold of it, you can then query it and say, well, who is the person who has this Library of Congress identifier? Who is the person who has this VIAF identifier? You could to some extent you could try doing things with the actual string form of their name, but I think as we've seen previously, that can be problematic.
Yeah, and the advantage of going through this route rather than, say, interrogating Library of Congress, the authorities directly, there is more information on Wikidata. Is it a better format to interrogate because you can directly question it in this SPARQL?
It's going to come. I mean, I think a crucial thing is it's going to come from outside of traditional library domains. So you're going to find out information about Brian Cox that a library itself would not curate and perhaps would not even, would not want to know. They might regard it as information that shouldn't even be there. But if you want to, be absolutely certain about that person. I mean, a bit that you always cut the best stuff out of your presentations, but a bit that I cut out was that if I had directly dereferenced the id.lsc.gov identifier, I would have got back some information about Brian Cox, the actor, but as you say, much less of it. And
yeah, do you feel that with the Wikidata you can trust the authority that you're relying upon?
I would be hesitant to in any way suggest myself as a Wikidata authority. I think in a sense it depends on your use case. If, as I was saying there, if it's just a question of pushing stuff back to someone, then you can trust it because the ultimate arbiter is the person who the stuff is being pushed back to. So you're just, worst case scenario, you're just coming up with false positives. If you've got something that's more, this is going to happen automatically and you cannot then, fiddle about with it, I would be more hesitant, but in my experience, it is not full of rubbish.
No.
But you would perhaps do well to, as I would say, to find, the same bit of information represented twice or almost represented twice before you're doing anything critical with it.
that seems to be one of the points that you're making, is that redundancy in a lot of these cases is a strength. I mean, would you describe it as such when you're thinking about the records that we're talking about? I'm sure someone could argue that it's a weakness of MARC records that they have this redundancy in them, because it makes them flabby, kind of. But you're viewing it as a strength that you can interrogate to tidy up the data, although presumably not just internally, because if you've just got two things that are inconsistent within one record, you don't know which one's correct without referring to an external source of some kind.
Sure, yeah. I mean, and I would probably see it in both terms depending on what it is that I'm doing. Because I was talking about that issue of, are these things created from separate edits? So again, my workflow would be that yes, they would be. I would be having separate edits to put in, any single bit of information. So that, that is time consuming and it is a weakness in that sense. But then when you come to the end of your process and you want to say, right, how good is what I've come up with, it can actually be viewed as a strength. So it's almost my presentation was almost a sort of apology to MARC for my previous frustrations with its flabbiness, and saying, well, actually, no, there are some uses I can put that to.
Yeah, Beth has added that the Library of Congress program for cooperative cataloging recently kicked off a Wikidata pilot project. We have a question, or rather, So, for example, automation could sometimes be misleading. Vaso mentions 546 leads to 008B for bibliography, but then to use a genre 655 from bibliographies is wrong, as 546 and 008 mean two different things. Items of bibliography, an item contains a bibliography. Yes, that's a good point. How do you sort out this inaccuracy? I presume that might just be one that you wouldn't rely upon.
I mean, in practice, I think how you sort out is that you put something in and you think it will work, and then you test it and it turns out not to work, and you say, right, okay, there is, you just run, big batches of stuff across it, and you iteratively come up with something that is both automatable and actually is trustworthy. And I have tried things and they don't work.
You consider a lot of this to be more a means of flagging up something that that potentially has problems, rather than for automatically fixing things.
I think depending on your working environment, where you want to put the pointer on that line. As I say, in my working environment, we can have it very strongly towards flagging stuff up and having hand curated changes. But if you are working with enormous data sets, you're going to put your pointer further along. And as long as it's understood that that's what's happening and that's where these records are coming, that's where these data is coming from. I think it's fine whatever you're doing, as long as stuff doesn't sort of, as it were, get into the wrong pot.
I've just got a final question before we move to the break. So how would you see individual institutions making use of the system that you're suggesting? Do you think it's a useful set of programming skills for individual librarians or systems people to work on? SHACL, for example? Or would you think that this needs to be done in more kind of collaborative fashion, or by the experts potentially?
I mean, there is a danger, I think, if once you have a hammer, every problem looks like a nail. So it's I would not for a second suggest that everyone should go out and start finding ways to use SHACL to improve the quality of their data. But if if you have a project that you are working on and it turns out that is the way of solving it, then fantastic. And if enough, as it were, if you were to solve enough problems in that fashion, then you would have migrated to a linked data environment almost by accident. But it's not going to be the appropriate technology for everything, or
No. Well, thank you very much. That's very interesting. So we are going to move on to a break now.